All right, our unit 4 is the two variable data, 5 to 7%, but I think many of the ideas are kind of found in more areas than just this one. We've already done a lot of this because right before unit 10, we pretty much reviewed all of this already. So just remember there is a strong, there is a weak, positive or negative, linear. Is it linear or is it nonlinear? We want to talk about the shape, the association between the two variables, positive or negative, and then if we have any outliers or unusual points. We've gone through the correlation coefficient, strong, positive, negative, linear relationship, coefficient of determination, the percent of variation in y that can be explained by the changes in the x, or it can be explained by the linear relationship between them. You know your slope, y-intercept. We've talked about how with extrapolation, you are making a prediction far outside the domain of the data. So that function can change and not be linear outside that area. So that's why that's dangerous to extrapolate. Now, interpolation, that's okay. That's making a prediction based off of the area where the data created that association. All right, remember our high leverage, a leverage point, a point's leverage is high if the x value is far from the mean of the x's. So if it's far out there, then that point has a lot of ability to make change. It has the potential to be influential and really change the equation of that line and the correlation, okay? So the influential point definition is that if you removed a point and it is impacting the equation of the line, and particularly the slope of the line, then that would be considered influential. And remember our standard deviation of residuals, the average amount that the actual y is varying from the predicted y, and that standard deviation of the slope. If you take many samples, then the slope would vary about this much on average. Now, remember we did our residual things before when we practiced. Actual y minus the predicted y. Also, your observed y minus what's expected to happen. Here is this. Oh, remember that all the residuals do sum to 0 because that line is there in the average of them. So you got the positive residuals and the negative residuals, so those will sum to 0. The least squares regression line happens where there is the smallest sum of those squared residuals. That's an important fact to know, idea to know. So if you think about this, here's our line, and you had these little pieces of data around it. So this, you have your point, and then here's your residual. Well, that gets squared. Okay, here's another point, and you have its residual, and then if you square that residual so that it's a positive value. Same thing down here. See, adding up the residuals doesn't do anything because they add to 0. So we add up the squared residuals. And the location of this line where the sum of all these areas is the smallest, that's where your line is supposed to be located. All right, remember, if there's a pattern in the residual plot, then a linear model is not appropriate. Now, if we want to go ahead and I think I'm going to, we've talked about transformations. You can add, subtract, multiply, divide. You can even switch the x and y, and that will not change the proportionality of your correlation coefficient. Okay, and so I think I'm going to do a little second video on this part here. I wanted to kind of keep these short. So there was that one, and then I will see you in the next video where we talk about these computer printouts.